if we're running code on a device we don't own, then it's open source. The code is open source and you can see what's happening, because really you should have a right to know what's running on your device. Even if we decided to, be malicious and stuff, we still couldn't take any of your funds. The hardware signer will only make a payment with its key, which actually holds your money, if it receives a signature from one of your devices, like your phone. The idea that software just isn't enough on its own, no matter how cool the software is, how much you optimize it and everything, having the hardware as well is so important to having everything work. Raspberry Pis are not designed to be used as a 24/7 payment device. They don't have error correcting memory in case things go wrong. Simply, the hardware is not built for, even if you had a legacy finance application where they're not doing all this cryptography and stuff, they wouldn't dare run something on a Raspberry Pi simply because the hardware is not good enough.
Azz is the 16-year-old founder of Valera, a company uniting hardware and software to bring lightning payments to billions of people. In our conversation, we discuss Indra, which is Valera's Lightning node runtime for enabling near zero cost Lightning nodes. We also discussed the idea of connecting your Lightning node to cold keys or wearable devices. And finally, we discussed the idea of using software and hardware and uniting them to build better products. Azz has also been added to today's show splits. So if you enjoy this episode and if you learn something new, the best way you can support both of us is by sending in sats over the Lightning Network. You can use any Podcasting 2.0 app, but my favorite to use is Fountain. Before we get into the show, just a quick message from our sponsors. Today's show is sponsored by Voltage, and Voltage is building the Lightning Network infrastructure toolkit built for engineers. Today's show is also sponsored by Stackwork. Stackwork is a lightning-powered transcription tool that takes the best of AIs and humans to create better, faster, and less expensive transcripts. We'll have more from Voltage and Stackwork later in the show. Azz, welcome to the show. I'm excited to talk about this latest project that you revealed a little bit about on Twitter the other day, and the work you're doing at Valera. But before we get into it, why don't we step back and why don't you tell listeners about how you first discovered Bitcoin?
So I discovered Bitcoin for about a year and a half ago, roughly January, by accidentally stumbling upon Stacks, which was is a Bitcoin, I'm going to say Bitcoin derived project, and sort of went from being interested in the project to developing in the ecosystem there, and we sort of built up a massive development community, tons of projects and stuff. But then over time, for example, I was involved in the City Coins project. You might have heard of it. But over time, we sort of, me and some other core members thought more about the Bitcoin Maxi side of things and thought more about the ethics. And sort of when you get higher up into the hierarchy, you can see truly what's going on. And we did. And then as a result, we left the Stacks ecosystem and we've gone on to found two separate companies, TrueBit and Valera. Sort of, we're friends. The companies aren't completely related, but we've sort of been almost like sister companies since we moved on from Stacks.
Are you able to reveal some of what you saw at the higher up levels at Stacks that turned you off from the project?
Probably just the general attitude from some of the community leaders, and it sort of, because I founded my community to create technical projects and create developers and experiences that would actually change people's lives, but it ended up feeling like all the leaders want in the community is to make a buck for their pocket, which is exactly what the Maxis have been saying the whole time, and they were right.
Now, okay, so you left the kind of Stacks ecosystem. You decided to build on Bitcoin. What was it? When did you make that realization that it was Lightning that you wanted to build on?
probably December, January of like a year back. So yeah, because we've been working on Valera roughly since, well, Valera related things roughly since January of this year. So it's been very undercover and there's been a lot of work under there, but yeah.
And what was it about Lightning that attracted you? What made you go, of course, this is what we should be
the
building on?
Because ultimately the biggest change we can make in people's lives is by changing their money, changing the way money works. And Lightning is just has such huge potential behind it. One as just a sort of, technically it's very capable currently, but also just because we're not talking about like a concept anymore. Lightning is pretty, even though it's relatively niche. If I can make $1,000 payments over Lightning from my node, pretty easily, and I can make that in milliseconds, and that's not like a tech demo. That's like me buying like ramen for my friends at the store today. Right, I paid for that over Bitcoin from my Lightning node, and it's stuff like that where I can show off to them, like, this is what I do at work. That's the sort of thing I want to do, because Lightning just has such huge potential to change the world, and mostly the fits the money fits the world slogan is very true, because a lot of the world's problems are rooted back to their legacy financial system, and Lightning is the best way to onboard absolutely everybody in the world to this fairer, equal financial system on Bitcoin.
Now, was Lightning something that you discovered after leaving the Stacks ecosystem, or had you been following along with progress over the last few years as well?
So I've only been around Bitcoin for like the last 2.5 years, I think, roughly. For context, I'm 16.
Okay.
And so it's been quite a, stepping stone personally to get up to sort of these levels. But the main, while I was in stats, I was paying attention to Lightning for a while, for quite a few months throughout, how, because my personal payments, I held, even though stats was probably the main thing I was working on, I held all of my capital and stuff. I held it all in BTC, at least for the most part. So, and then when I wanted to spend, I've tested out basically all the mobile Lightning wallets. I've used LND. I'm currently on Core Lightning, on a custom server, and which is working out for me great so far. But yeah, while I was at Stats, I was using mobile wallets. I was using Moon, Zeus. Well, not Zeus, sorry. Phoenix. Phoenix is a great wallet. I'll put that out there. I have no idea how it works behind the technical scenes. Actually, I should take a few guesses, but I'm not that familiar with, let's say, Claire compared to Core Lightning and LND. But Phoenix, as an experience for me, Phoenix was an awesome experience. I've also tried Breeze, but personally, I've preferred using Phoenix over it. But yeah, there was definitely a lot of use of Lightning, and also even discussions of bringing like stacked things onto Lightning, but really it was more of a personal thing, like to get on Lightning. So yeah.
Yeah, that's really interesting. So you're 16 and you've been building on Bitcoin now for a couple of years, and you recently unveiled, or you kind of teased, this project that you've been working on at Valera. Is it called Indra? Is that how I pronounce it?
Yep, that's right. It's named after the Hindu god of
Right.
lightning,
Yeah.
and
I had to look that up to see what the naming was behind it. But you had this tweet storm, and it started off with a tweet saying that you're building a Lightning node runtime called Indra using LDK. Can we maybe give everyone a high level understanding of what is a Lightning node runtime and why you chose LDK?
um there's quite a few options in the Lightning space for node implementations. So you've got Core Lightning, LND, massive popular one, Eclair, which is less known but also probably the third choice, and also various smaller ones that have been built specifically for mobile wallets and stuff like that, built custom. But what really stood out to us for making things stale and efficient at the scale we need them to work at was LDK, because of the amount of programmability you get into. You're not just interacting with because LND, CLN, these are basically programs by themselves, and you don't really have much input into them, except you can put plugins, but that's not really the same thing. But you don't have code control over everything they do, like very in-depth control, technical control of what they're doing. Yet with LDK, they did something completely different, and basically instead of building a Lightning node themselves, built a sort of a set of code libraries to build Lightning nodes, which is why it stood out so much to us. And as a sort of definition, a node runtime is not a node itself, but rather you just say quote unquote looks after other nodes. So it manages everything they need to do to stay active and work and function. So unlike a regular Lightning node where you have you basically have one node, you have one public key, for example. We can have hundreds of thousands of public keys under one runtime on one computer, which is a massive deal for scaling things.
Right.
So yeah.
And you went on in this tweet storm. I think we can just kind of like walk through it for listeners. One of your next tweets was that this will enable what you call always on, semi-trusted, and non-custodial nodes for essentially zero cost. Can you talk through this semi-trusted setup and how that works?
So the semi-trusted setup is sort of, you have to imagine that if you're running a Lightning node yourself, for example, on your phone or on your own Raspberry Pi at home, then you have all of the data available to you. All of the storing channels, storing payment information, stuff like that, all happens in your node at home. No one else can see that. The way the semi-trusted bit means we have the channel data, we have to store that. And obviously we're not doing anything with it. It's purely on the technical side, it's literally raw bytes, and it's encrypted for the node. But the semi-trusted means we can't spend the user's money, but we do have access to the data behind it, if that makes sense. So the data that would usually only be available to the node runner, like you, if you're running it at home, that's available to us if we really wanted to. Obviously, as I said, we don't actually use that, and in the technical implementation, it's used for nothing apart from your node, and most of it is done all client side, e.g. on your app on your phone and on your devices, which will be, and all the code for apps running on your devices will be open source, so you can see everything that's going on with those. The sort of policy we have there is if we're running code on a device we don't own, then it's open source. The code is open source and you can see what's happening, because really you should have a right to know what's running on your device. For our server side stuff, we own the servers and we have a right to hide what's running on them. I think that's sort of a fair deal, and if we want to share access to that code, we can do. So that the semi-trusted architecture is quite interesting, because while we can see some data, but we can't spend your money, because ultimately we need your keys to do that, but your keys are secured on a hardware signer that's at your house, that's completely open source and will basically protect your sovereignty. Even if we decided to be malicious and stuff, we still couldn't take any of your funds. We can't confiscate them or anything.
Right. So this hardware that you might run these Valera node runtimes on, does it take the same form factor as something like a Raspberry Pi, or what does that look like from a hardware perspective, and how is it different from what someone might expect if they're hobbyist today?
The quote unquote node runtime that runs the Lightning nodes runs on our servers.
Okay.
It runs on our servers, but the runtime connects to effectively what the equivalent is of a internet connected code card, basically. But instead of you directly interacting with your code card, like, you know, putting in a pin and stuff, all it is a little brick with a screen on it that you plug into a USB socket, and then you can control it with the app, open source, obviously, from your phone. And effectively, what it does is that is the device that actually holds the keys to spend your coins with. That is the thing that will have a direct connection over the internet, obviously encrypted to the runtime. And whenever the runtime basically says, hey, I want to spend some funds, for example, it has to go back to your hardware signer, right? There's no way for the runtime to spend your money without the hardware signer. So they're actually they're very lightweight, even more lightweight than a Raspberry Pi, for example. But the sort of difference is that you don't interact with them directly. When you make a payment, instead of like pulling your cold card out, you'll use a different device. Could be the app on your phone, could be a payment ring, which is one of the things we're working on. But basically, those devices have everything is on a cold. Everything uses cold stored keys, as in keys that are never like stored as a file on your computer. For example, LDK, and other Lightning node implementations, which basically just store it as a file on your computer. These are stored in hardware secure enclaves, both on the hardware signer, which is a custom thing, but then if you have the app on your phone, we're putting your keys inside the chip on your phone, right? And it will never come off that chip on your phone. And this is basically having a lot of devices all connected at once means we never actually need to have a hotkey for Lightning, and you never have to interact with your hardware signer at home, because your hardware signer trusts the key that's in your phone, right? And basically, the hardware signer will only make a payment with its key, which actually holds your money, if it receives a signature from one of your devices, like your phone. Which also means offline payments are completely supported, right? Because your RIN, which is not very smart at all it does is when you hold it over a reader, over NFC, the point of sale terminal basically sends almost think of it as like the Lightning invoice to your RIN. Your RIN does some very basic parsing so it can work out the amount and stuff, then shows it to you on a little screen. And depending on how you set up your RIN, for example, if it's under like a $10 purchase, then you might just have it automatically sign it and you don't have to do any confirmation. But if you want to do a certain amount that might be a bit higher, a bit like Apple Pay, you have to have user confirmation. So actually on the back of the RIN, you can squeeze it, and that's the user confirmation we get. A bit like how you can squeeze the tip of the AirPods Pro to like play or pause a track. It's the same tech where you just put it in the back of the RIN, and then your RIN will basically use its key, which never leaves. It's not a hotkey, it's a cold key, but that key doesn't actually spend your money. It just identifies from the RIN. It authenticates that the message came from the RIN. The RIN then basically gives that back to the terminal and never talks to the terminal ever again, unless you make another payment. So it's a very quick one-way thing there. The terminal will then do the effort of then using a onion message to basically go and talk to your node and basically say, hey, I have an invoice here that you need to pay. I have proof that one of your devices have paid for it. Here's the signature from the device. Then that will wake up your node, because in our case, that node is on Lightning node runtime. So it will go to our server. Mm-hmm. Our server will go, okay, this looks okay, but really I don't have access to the keys. I need to send it back to your hardware signer for the actual payment to happen. The hardware signer then goes, hey, I recognize this public key from the RIN. Like, oh, this is Azz's RIN. This is an authenticated device. In the last hour, it's made this amount of payments. It's under its hourly limit. This is all okay. And in exchange, then it sends the signatures it uses its own hardware key to make the signatures to make the payment and sends that back up to Indra. And basically, this all happens with the tap of your hand on the contactless pad, like like a regular Visa card or something like that.
This is fascinating. So,
Well, and during that process, you will also get automatic end-to-end encrypted receipts back to your node, and all the data from the transaction, all the vouchers and stuff that you might have. That's a wrapper protocol that all happens automatically. All your vouchers are selected automatically for that order and paid for automatically, and all you had to do is hold your own up to it.
wow. So, at a very high level, there's this node runtime that's operating on your servers.
Mm-hmm.
It is talking to an internet connected hardware signer like a cold card,
Yep.
and that can then communicate with a ring or a mobile app, some other interface that you might want to use to actually make a payment if you're on your phone or you have a ring on your hand, right?
Yeah. The awesome thing is because it's the actual keys are disconnected from the authentication, that completely opens up the field for first party and also third party apps and hardware, right? Because now you can also have your web browser, instead of your web browser holding its own keys and managing a Lightning node in its browser and doing all that wacky stuff to try to get that working. All it needs to do is talk to a traditional API which basically talks back to your hardware signer, and it keeps its own key, which it then uses to basically prove that it is an authorized device to your hardware signer. Which means we could see like a third party, someone could make a WebLN wallet with this, right? And all
Right.
they'd have to do is integrate the client side APIs, and they wouldn't have to think about the Lightning node. They wouldn't have to think about all the sign-in capabilities. It would be super easy to make, which also it opens up so much potential for third-party developers too, because now you can basically build whatever you want on the client side.
Where does your mind wander when you think about the things that third party developers could build? What are some of the ideas that have come to mind?
Um, Something specifically, I remember having an app on my phone. There's a sort of similar thing in the banking side of things. Obviously, it's horrible to use, but you might have seen apps that basically connect to your bank account and then do, like, for example, they can do tracking and like tracking on your transactions and do like instead of your accounting you have to do manually, it can basically auto do all your accounting for you from your transactions directly from your bank account. And someone could build something like that with the API on the front end.
Right. So you have this like accounting system built in and it's just
Mm-hmm.
pulling data.
But also now, but then you could go from that. But then also, for example, a game on your PC, right? A game on your PC could basically ask the app on your PC from like Valera, for example, and it goes, "Hey, I'd like to connect and use this as a Lightning integration." Um, and all it has to do is use the same API that everything else is using. The first party apps that we will make are completely open source, which means people will be able to get inspiration from how we do things in our first party app, build them into third party apps, and really just open the whole market for other people who want to integrate it. I mean, there's so much like potential there just on the front end, because that allows not only do you get all the apps that will be built on the web and stuff like with WebLN, but also all the apps and things that need their own Lightning wallets that would previously rely on custodial services now just have an immediate onboarding, right, to the Lightning ecosystem without needing to think about all the Lightning behind it, while also not being custodial.
Right. Wow. I want to touch on this, cold key setup where you don't have to have your keys on a computer connected to the internet. You can have it on an external hardware signer. Why has this not been done before why are none of the other Lightning projects taking this approach?
There is a project called VLS, which is Validated Lightning Signer, and they are currently working on something, and they have something working for LDK and CLN, I believe. We still need to check the code out, but it's definitely going to be something we either integrate or take a lot of inspiration from for how it works onto our backend side. And even if I'll put this completely out there, but if it goes really well, then it might be cool to have some of the developers that have been working on VLS as an open source project. We could, I think they have exactly the right skills. We'd just be looking for, like, for software engineers here at Valera, exactly the right backgrounds too. So if they'd be interested, this is not a job offer by any chance, but and we definitely need to still look into things. But like that could be, cool thing, because work has already been done on this front. It's just sort of tidying up and turning it from a technically possible thing to something we can ship to billions around the world.
I love it. What does this do to Lightning security when you have keys stored on a cold device? Like, what changes do you expect to see in the ecosystem when it comes to security?
Well, the thing here is that it's greatly improved, as you'd imagine, just from moving hotkeys to cold keys is always a great security benefit and also privacy. Um, but the another philosophy we have here is that the hardware will basically keep any software in check. Um, Meaning, even if Valero, well, let's say, had a massive hack and decided every single person's node had to be like attacked and would be stolen, like you could do with a custodial service, it would be a lot easier to do with a custodial service than us. But if you say that does happen, which would be catastrophic on our end, and it probably won't happen, but say if it did, they'd get absolutely no funds out of it, and also they'd get no data out of it either, because not only is the keys to spend your funds on the hardware signer, but the runtime will actually ask any unencrypted things it needs to run the node with will only be kept in memory, and as soon as the PC is shut down, it completely forgets about it. As soon as the server shuts down, sorry, it completely forgets about that. And every time it turns on a node, it needs to basically talk to the your hardware signer to basically go, hey, could you decrypt this for me? And like, can we just use this for a minute? And your hardware signer goes, yeah, sure, and decrypts it, because it can't spend your money, it's just like checking. So that sort of protects it too. And like, even if you had like a complete copy of our whole database, be completely useless to basically a hacker if you think about it. And but that's only on our side. If you then go into a normal Lightning nodes, which either run in hot wallets or hotkeys like they do on your phone, or they just run on, let's say, a Linux machine, which might not be firewalled off properly. It might have, security vulnerabilities, stuff like that. Um, Storing keys on a hot system is never a good idea. And but then now that we can, this is where the hardware keeps the software in check, because you should basically never trust software that can be modified, but you should have trust in your cold card that when you turn your cold card off and turn it on again in 10 years, it will still work exactly the same way, right? That cold card is never going to accidentally delete your funds if the firmware is right. And we have basically trust in the fact that that hardware is pretty secure. The hardware is basically what secures everything in the Web 2 world too, because when you boot up your operating system, it talks to a hardware chip to make sure that a hacker hasn't changed the operating system that you're loading up, right? Hardware protects basically all security and is the root of all trust in the system. And basically what we're doing is just making that into Lightning, by basically having not only the keys but also the access control on your hardware signer, because not only is it for example, validating Lightning signer, which basically works out whether it's been stolen funds from or not, because effectively, if the runtime is going, hey, I need you to sign this, the signer shouldn't just go, oh, here you go. It should go, oh, am I receiving money? That's fine. I can sign that instantly because, there's no risk to me. Or am I sending someone money? Right? I don't want to do that because I haven't had proof that the user actually wants to spend this. So actually access control is a massive part of it too. And which is why all our client devices like the payment rings, first party apps and stuff, you can all set limits like on them as if they were almost Visa cards, right? But they're custom limits. You can change how much you can spend hourly. You can even freeze a device. Like if you lose your payment ring, you can go on your phone and freeze its access to your funds instantly, right? Um, and also, even if the internet's down, you can do this all from Bluetooth, right, and connect to it directly. And then if we go even further than that, and then go into sort of where else did I want to go with this? Oh, mind blank.
Okay. So I just want to clarify the let's say the worst case scenario for if we can do like a compare and contrast. If I'm running a Lightning node today at home, say it's on a Raspberry Pi, what is the worst case scenario for something going wrong? And what is the worst case scenario in Valera if something goes wrong, someone gets hacked, if you guys get hacked, there's no funds lost in that process, right? Can you
No,
kind of compare and contrast what?
for a Raspberry Pi, yeah, you probably lose everything.
Hmm.
If anything, the biggest risk on a Raspberry Pi is either you setting it up properly and protecting it from, the evil quote unquote hackers who are trying to break in, or the hardware failing. Raspberry Pis are not designed to be used as a 24/7 payment device. They don't have error corrected memory in case things go wrong. Simply, the hardware is not built for even if you had a legacy finance application where they're not doing all this cryptography and stuff, they wouldn't dare run something on a Raspberry Pi simply because the hardware is not good enough to run it.
Hmm.
Um, the 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 thing that would happen, probably the worst case scenario with Valera, isn't us getting hacked, but probably you just getting the traditional $5 wrench attack, right, or
Right.
$10 now because of inflation. But if you the problem is on that front, but then that's not really a Valera issue. That's a sort of a general security issue at that point, because the one of the interesting things I remember now what I was going to say about the hardware devices, this signer that you keep at home, you don't interact with this directly, right? You can't when you make a payment, it's not actually making a payment from your RIN to the hardware device. It's going from your RIN to the terminal through the Lightning network into your node, into the runtime, back to your signer, and then back to the runtime to make the payment. Which means if someone comes around to your house, unplugs your signer, steals it, and then tries to blackmail you, there's basically absolutely no way they can get the funds anyway because of that hardware security. Because that live signer is what we're calling it. That live signer will not unlock without a valid signature from your devices, right? From your client devices. It won't unlock its control. It's not like a code card where you can guess the pin or something, because that's user interaction. This thing will literally just not talk to them, right?
Hmm.
And if you want proper secure setups, for example, when you're going into generational wealth or corporate wealth, we're talking about multi-sig live signers. You can geographically distribute all of these live signers. Obviously, that adds latency, but latency is not a problem when you're securing billions of dollars worth of Bitcoin, right? Um, what's more important is not losing the billions of dollars worth of Bitcoin.
Right.
So having them not be interactive, then they'd also have to steal multiple of your live signers to try and break in. Or even if you're running like a 2 of 3 setup with a multi-sig, you can even that's almost redundancy. If one of the live signers just breaks or gets stolen, the whole funds are still fine because still have 2 signers available, right? And
Hmm.
even if you have a power cut at one location, the other 2 will still be available, right? That's sort of, if you want, this thing scales from absolutely everything down to like individual people, like a single person, living in an apartment by themselves, to families where they can all share one live signer. They don't have to buy one per person like you would with a cold card, for example. They can all just use separate access controls on the live signer, all the way up to massive corporate vaults that are spread across multiple data centers. They might be behind massive firewalls and stuff, scattered everywhere to protect corporate assets. Um,
Right.
it scales from that all the way up, which is sort of the magic of the security model.
I hope you're enjoying the show so far. Just a quick message from our sponsor. Voltage empowers engineers with the tools to integrate Bitcoin and Lightning Network payments within their business stack with an enterprise-grade experience. The team at Voltage is building the complete toolset so that you can do more than simply spin up nodes, but you can also understand and interpret your node's data. Their new product, Surge, gives engineers the ability to quickly solve problems and optimize their operations. With node insights and visibility through time series data, you get dynamic and complex insights that were never available before. You can get complete control of your Bitcoin and Lightning tech stack with insanely fast onboarding, advanced client-side encryption, and zero management infrastructure to make backups, networking, and upgrades simple. Get a free 7-day trial today at voltage.cloud. Now, one thing I want to bring up on the scalability side is you mentioned in your Twitter thread that you could bring the cost of operating a Lightning node down by about, I think it was 10,000x
Yeah.
to effectively zero. Can you talk me through how that works?
So effectively behind the scenes, your Lightning node, how the runtime makes it so efficient and runs so many of these at the same time is by ironically not running all of these at the same time. Because traditionally you might need like a server, like a virtual server for each one or a Raspberry Pi for each one, but that doesn't scale very well. And because of how CLN and the other node implementations are built, that's sort of the way they expect you to use it is one node per server or a few nodes per server. What we're doing is the complete opposite, which is thousands, hundreds of thousands of nodes per server, right? We're literally the main limitation here is not actually the compute and memory resources of the server, but actually the amount of ports we have available on the machine and like internet addresses we can actually give you. That's what it's limited by, because that 480,000 comes from 10 IP addresses with 48,000 ports open each. And that will probably be less per IP in production because we will have to keep some open. But generally, that's the sort of thing we're looking at. The way it gets it down by is by not running them all at the same time and only running them when they need to be active. Basically, the runtime pretends to be the nodes it's running. So, for example, if you're running a Core Lightning node, which is a full node that runs on your server, to the rest of the Lightning node, to the rest of the Lightning network, including your full node, one of the nodes on Indra is a completely normal node because it's basically doing a ton of things to make it seem like it is a completely normal node. Unlike a mobile node where your mobile phone could be out of signal in some places or not be available, you can't open ports on it because of firewalling and stuff and security. Instead, we will literally pretend to be your node if we need to be. For example, sometimes if there's a message in Lightning, which is the pin message, to basically check, hey, are you awake? Basically from another Lightning node, and you respond pon back. Very simple message, but that requires absolutely no. We don't actually switch your Lightning node on to actually do that. We actually we pretend to be your node from the runtime and basically say pon for you, and we don't even boot up your node in the first place. And these nodes are expected to be not routers like, for example, like zero fee routing or even like my personal node, but rather they're meant to be light nodes that, how many coffees do you buy a day, right? You don't actually use your card that often per day, so we can achieve that scale because simply you're not using it most of the time, and we can shut them down. And then by basically bundling all of that into one thing, we can make it super efficient and basically cut the average costs down.
Okay, that makes sense. So this is a highly efficient system where you can run up to, I think it was 480,000 nodes in one server, but there are potentially performance benefits to still operating one node, one server if you are a zero fee routing or some big routing node. Is that correct?
Yeah, of course. And in fact, what we're talking about here is purely the light nodes, effectively. What they are is light nodes almost. So when you think about that compared to those light nodes will need to somewhere to send their payments over, which will be one of our LSP routers. It won't be, though our routers will be custom made in LDK because we have a lot more features to add into our LSP than just the basic Lightning node capabilities. And also we want, that programmability over the, and we like building things from the ground up and engineering them to be exactly perfect for what we need them to do. So in fact, we have Indra, which will run hundreds of thousands of nodes on one server, and then we will have our own routers, which will probably be closed source because they don't need to be open source. Because the likelihood is you won't be running these with like 10,000 transactions per second, right? And for your average, self-sovereign operation at home, you can just use CLN or something else. Our LSP is very designed and custom designed and engineered for our internal networks and stuff like that. You don't really need to see the code behind it as long as you know it's a Lightning node. And that one will use, it might even run one node across multiple servers, for example, because at that scale you might need to, a bit like Eclair does, or the Eclair lets you do, is run it over multiple servers. So there's a lot of there are two extremes, I suppose, because one is hundreds of thousands of transactions per second capability, which is the router, and then the others are like not even one transaction per second on average per node.
And so on Indra, do you expect that the ability, like if I'm trying to pay for, let's use the classic pay for a coffee example, will I have a faster experience on Indra or running my own node and trying to connect that?
Indra, easily, because not only are you, but also it'd be way more reliable too, because instead of going and relying on your node to do all the pathfinding calculations, and also one of the things, when you have 480,000 people making payments, one of the advantages of this is we can actually share the pathfinder, right? So usually your Lightning node learns by, making payments by itself. When you buy a coffee and it tries 30 different ways, and you have to stand there for 15 seconds while it does to find the right route, and then it goes, hey, I found a good way, and then it records that route. But instead, now we've got 480,000 people doing that, and all of them have and it's all under one pathfinding algorithm. So our algorithms that run in Indra, not only that 480,000 person per server, but then Indra runtimes can actually connect to one another. So you'll actually find them sharing and improving each other's route calculations. So that's efficient by itself. But then also, if you're using Indra, you're probably going to be using LSP too. And our LSP is a beast by itself. So the sort of goal is to have 99.99% or something of the Lightning network available at any point within 2 hops. which is quite the liquidity goal. And that just means your payments will get there a lot faster. And if they don't get there, we will, our LSP will try the hardest to get that payment to where it needs to be. Even if that means opening a channel, or for example, if the shop has run out of inbound liquidity, and traditionally your phone would go, oh no, it couldn't receive the payment because they didn't have enough liquidity. You won't find that out. It just said payment failed. But for our LSP will basically brute force and splice open their channel, add more inbound liquidity to it, put your toffee payment through, close the channel, zero confit, and then basically put the payment through instantly while opening the channel. And basically, it will try its absolute hardest to get that payment to where it needs to be. Is basically what I'm saying. It will be. The idea is that the LSP does everything from currency conversions and replaces your exchanges, which is a whole new conversation. But it does everything from currency conversions with Taro and stuff, all the way to virtual channels, which are basically, if you think about it, most LSPs currently use effectively one node to source because that's most efficient. But we want to use multiple ones to lower latency around the world because we're talking about onboarding the whole world here. So our nodes will need to be able to send payments to each other. But the problem is that over Lightning, you usually have to have channels to to send the payment over. And then when you have channels, you have to think about rebalancing and stuff like that, which is a real pain when you're trying to, especially when all the Bitcoin, the advantage of Lightning is that it's trustless, right? But I trust myself, right? Our LSP node in London trusts our own LSP node in New York because we're owned by the same person. It doesn't matter if it makes a payment to the node in New York, because that money is just moving between inside the same company, right? That's absolutely, it makes no difference which node it exits, which is why we also use virtual channels, which are basically, imagine infinitely sized channels that don't actually exist on chain, but the nodes will act like they do exist. And when, for example, if you made a payment from London to New York, or a node that's connected to our New York node, it will send the payment and forward the payment from London to New York without actually a channel in between it. It will basically send the message that says, hey, you need to send this payment, but then the New York one will recognize that, hey, this guy is also owned by the same company, and there is no need for a channel between us, and it will send it over by itself. And it's sort of all those magic things in between that basically power that LSP to make it like the most reliable thing you could, like probably more reliable than Fiat at that point.
Wow.
You could, so
I
yeah,
want to
there's
touch
a
on
lot there. Sorry to digest.
No, that's incredible. I want to double click on the reliability, because when you were talking about how you can start to learn the pathfinding from all the other nodes that are on this runtime, and then share pathfinding between runtimes, it's almost like you're building this like hive mind that is now other nodes are able to like collectively figure out what the optimal path for a Lightning payment might be. What do you think this does to, if a lot of people come in and adopt Indra, what does this do to payment reliability on the network as a whole? Right? Like, is this something that builds upon itself to the point where everyone wants to use Indra, in the same way that, Google search was this little hive mind that, as people started using it, as sites started getting indexed, it just became this like beast that, of course, everyone wanted to be connected to Google and wanted to be using Google. It kind of like built on itself,
because
right?
they have the insights.
Yeah, they've got all the data, and then of course it makes the search experience even better, and then it kind of snowballs. Is that something that you expect to see on Indra?
Yes, I think potentially that could be a massive thing about what you said about the hive mind is definitely correct. Because even if we think about when we, for example, if you're in London, or if you're in the UK, you'll want your node to be running in the UK servers, right? But then if you go abroad, we don't want to, if you're making a payment to somewhere in China, and you're going from your client device in China to your payment the shop in China, you don't want to go all the way back to London and then London all the way back to China to make that payment. So actually, this is very technical detail, but the runtime actually agrees on where nodes should be, and will talk basically with other Indra runtimes and basically work out who should be running what node. So your node isn't just restricted like as a regular server would be to a regular location, like one location, like in London, but actually it can migrate in real time to be where you are. And the nodes will actually communicate with one another, because running two Lightning nodes at the same time is very dangerous, right? Because you'll get state mix-ups and stuff like that. But the good thing is we have hardware, like the live signers will actually be the root of trust anyway. There will always be the people, the devices that know the channel state, and they can protect against multiple instances. Even if Indra messes up and then starts running multiple versions of the same node, because the live signer is the one that's actually making the signatures, and there's only a few of the live signers, and they have their own consensus mechanism, they actually control and can protect against those events when they happen. Yeah, it's definitely a hive mind sort of thing, but payment reliability will definitely just effectively skyrocket almost exponentially, because it's a bit like Doodle, like where you have, as you said, like more you had Doodle's indexing, but then more people were joining and then providing more data and insights that then Doodle was using to train itself, get better. But then more people were joining because suddenly it's got better, and their work is, they can't use the old search engines anymore because they're less efficient. And it's that snowballing effect, because Indra would be basically learn so much about how the Lightning liquidity and have insights on basically every single channel in the network, because it's so it will have the capability to talk with other Indras who also have experience with dealing with those, and you have 99.9 or whatever percent we eventually agree on, put in as the goal. It will also have it will know where all of that is, and we're talking about basically combining instead of your one node, we might be combining hundreds of millions of users worth of transaction data, not in a like a privacy like not in a way that would threaten privacy, because it's all aggregated, and all it is basically learning the best paths. It doesn't really care that you made a coffee payment in London, right? All of that does is it basically add to a store that's then combined with everyone else's store to basically work out the most efficient path on the network. So
Interesting.
yeah.
Now, you are introducing a lot of new ideas in this conversation, a lot of fresh ideas that I haven't heard many people discuss. And I've had about 80 or so people on the show so far, and I'm really interested in hearing more about how you think about the things that we need to build in Lightning, what your vision is for Valera as a company, and some of the frameworks that you're using to think about these ideas, because it's refreshing to see new ideas pop up in interesting ways, and to be doing all this at 16 after only being in the Bitcoin space for a couple of years, it's really interesting. So I'd love to hear more about the vision for the company.
So the sort of if we go to the first question, which was like the general Lightning ecosystem as a whole, really we should really just keep doing what we're currently doing, which is we're putting new concepts together, making new apps that are really cool, but also at the same time we need to be consolidating our base layer and consolidating payment reliability and actually making it work all of the time on the bottom, because you might have, there was a really cool idea that we were discussing the other day where about a company that's working on Lightning payments and basically charging an electric vehicle with basically sats, and that is an absolutely phenomenal idea, right? But it will not work unless your actual payments go through. Right, they can't be taking 15 seconds to settle because it's finding a good route to do it in, and then erroring after you charge the 36% on your car because there's no more inbound liquidity. Right,
Is this
it
distributed
has to
charge?
keep working. It is.
Yeah.
Actually, I've submitted Indra for the challenge too. So
Very
hopefully,
cool.
we have to see what happens out of that. We have to find out specifically for the global adoption one, because I think it's a really big deal, because pretty game changer by itself. And then for Valera as a company in general, the vision is to onboard absolutely as many people. Well, probably a similar idea to many other Lightning companies. Basically, onboard as many people as possible to the Lightning network. But then at the same time, we don't want to be throwing these words at them like technical jargon, like the Lightning network, because people who use Cash App don't care about its engineering stack behind it unless you're a nerd and read their engineering blog, which go you, because I also do that, but but the majority of users don't actually do that, and we have to think about that, because most people don't care what a Bolt 12 or a Bolt 11 invoice is. They don't care if they're given a Bitcoin address by their friend, or that when I want to send a payment, let's say to you, right? And say you give me my phone number and we're texting over iMessage or something similar. When I go into my wallet, I just want to see your picture there and your profile there, and I want to tap your name, and then I want to send you a payment. I don't care if I want to send it from my USD account, if I want to send it in pounds and then you receive it in Canadian dollars. I don't care if you want to receive it in Bitcoin, that's your preference. I just want it to get to you, and I want it to get to you quickly and reliably. right? I don't care what happens underneath, and basically no one else does either. The thing is, we need to think about that more, because what we're doing is amazing, but most people don't care about the ins and outs of it. They just
Right.
care about the end product. But then that's not the only thing, because we want to open that up. We want to open. None of this happens, and we don't onboard everyone if you don't have cool apps to use it with. So
Hmm.
stacking news, the electric vehicle charging thing, all of that. That's why having third-party APIs and letting absolutely everyone basically connect in, and rather than limit it to like almost think about like, imagine a cash app, but absolutely all of your apps can basically plug into it. It's a bit like what Apple did when they introduced Apple Pay, right? Because Apple Pay became a system-wide thing, and now every app you go onto on iOS, when you want to make a payment, when you want to buy something with, there's a big Apple Pay button at the bottom, and you love using it because it's so simple, right? And you know it works, and it's so reliable, and it's really secure too, right? And that and that's the sort of, and if anything, Apple was is sort of a big inspiration here too, because the fusion of hardware and software that are so like designed to build to work with one another is basically what we think will change how Lightning works overall. And we don't even want to say lightning overall, but we want to say the finance system, right? We want to completely replace absolutely everything, and we have the possibility, we have the potential to, Lightning does currently. We just need to get it to the point where it's reliable, fast, and has all these abilities um, constantly, rather than sometimes your payment will go through and it would be really impressive to all your friends, and then sometimes you'll open your app and make a payment and then end up waiting 30 seconds for your payment to go through, looking very embarrassed and sorry for yourself, right?
Right.
We want to absolutely blow people's minds. And for example, my friends who are 16, they're in college, right? These people, they don't even have cash up on their phone. When they were paying me back today for the ramen I bought everyone, um, I was reading out my bank account details to them, right? But instead of that, when they download the app, they shouldn't need to buy a hardware signer. They should literally just open that app. There's no sign up, there's no please record your keys, etc. You literally just open the app and it's there, right? It will ask to see your contacts and some other permissions so it can work properly. But as soon as you onboard to that, and then as soon as I send you a payment, you can download the phone, sorry, not download the phone, download the app onto your phone. And I should then be able to see your contact pop up in real time when you download the app. Not me closing the app, refreshing the app, and then going back to see if your name's there. I want to see it pop up in real time with your profile picture, click on you, and have that same experience without, you didn't need to open any channels. You don't know what a channel is, right? My friends don't care what a channel is. It's really cool to them, but they don't care, right?
Yeah.
All I want to do is, send them some money or they send me some money. It doesn't matter how that happens in the first place, as long as it does.
Right. I think that's a
And it
really
does
important
quickly and
perspective.
reliably.
That's something that I hope we appreciate more as Lightning and Bitcoin development improves. I hope we take. I hope we start to consider some of these things that a lot of regular users who are not Lightning or Bitcoin nerds, they just don't care about, right? Like Lightning, at the end of the day, it is a tool and it's a useful tool, but it's not the thing. People don't want to see the tool. They want to use the tool in the background and have something magical happen on their phone.
Mm-hmm.
So I 100% agree with where your head's at there. I want to
If
touch
any,
on one other point on Indra. I think at the end of the thread that you wrote introducing the project, you said you weren't sure if you're going to open source it. Can you talk me through some of the trade-offs that you're thinking about in this process of whether or not to open source it?
so the biggest choice about open sourcing it is Indra is effectively Valera's special sauce. We have what no one else currently has, which is the ability to basically, if we, I don't want to call out any competitors' names because there's, I don't want to see them as competitors, but rather partners, in getting Lightning to the world and everything. But there is, from an investment standpoint, when we're pitching to investors and stuff, they don't want to see our tech just go from you know, from being a completely game changing to then basically being given out for free because they won't get return from it. The company basically won't be profitable, and we won't have the early on advantage that we do currently, because currently we can do things for 10,000 times cheaper than everyone else can. If we took that to a different market where that was a lot less niche, that would be a huge deal, right? That it would be so game changing, it would probably break most of the economy in that industry. Luckily, we're a niche one, so Indra won't be breaking, the rest of everyone else's code and businesses. But there's a we don't want to sort of give it away. I don't think it's ready to be given away for free quite yet. I mean, if centralization becomes a problem, and other Lightning companies might be struggling to keep up with adoption relative to us, which would be really good but also really bad at the same time, we will open source it, right? There's a difference between us wanting to keep our head start a bit and us completely trying to dominate the market and basically get rid of every other company that's trying to do stuff too, because that's just unfair, right? And also, it's not the way to grow a community or an ecosystem, right? That's like turning fintech into just Square or just Cash App, right? I mean, from a purely capitalist point of view, that sort of might be the one most people take, is then yes, it would be awesome just for us to have complete advantage and complete control over the whole market. But we don't want to do that, because there's a lot more than I suppose in the current world we live in. It's more of a hyper capitalist sort of view, which is purely profit. User data, user privacy, individual sovereignty doesn't matter, as long as you can basically completely break humans down to a data stream, right? That's not what we're about. We're about changing the world, but we still want to work as an actual company. So I just want to say there's definitely a limit to what we will say when we say it will be closed source and our server side stuff will be closed source. But then most of the other server side stuff that we use might not even be useful to many people, because it's so highly customized to our setup and our whole tech stack that it's probably not very useful to many people. Indra's probably the most useful, at least for other companies, to basically onboard users with. So we'll have to see. It's definitely not going to be a quick or an easy decision about whether it happens or not. At the moment, it will stay closed source, and definitely probably for a while yet, until at least maybe quite a few months/years into production, it will be closed source. But if it does actually start being a problem, not just if it starts being a problem, then yes, it is worth open sourcing it, and we won't hesitate to.
Right. Now let's do a hypothetical here. Imagine some other competitor or some other companies in the space find ways to decrease the cost of running a node by 10,000x as well, right? Independent of whether you guys open source or not, if the cost is now effectively zero across the industry for running a node, what do you think about as the competitive advantage for Valera? What's the moat that you
Then
use?
it starts to be the little things that start to matter. And if other people can get to that stage, if other companies start working on this and put in the effort to build all of this themselves and put it out to the scale that we do, that is utterly awesome, and I'd be very happy to have you as a competitor, right? If anything, you've basically doubled our because it's not just about growing the company, but it's also growing the ecosystem, because growing the ecosystem will naturally grow the company anyway, right? So it's not just a selfish approach, this is just me doing this. We need to get everyone doing this too. So yeah, I don't think it would be a problem in that scenario. If anything, it will be the little differences that start to distinguish. I mean, if you think about the difference between Breeze and Phoenix, isn't a lot, right? Personally, I prefer Phoenix, right? It's very little differences like that. For example, I just prefer how it's a native UI rather than using Flutter, for example. That's just a very technical point of view, but I liked the UI on Phoenix better than I do on Breeze. And that's simple as that. They're very similar in functionality, but I prefer one of them, and that's fine, because most of our users will pick one or the other. And and all of our stuff that will be the payment terminals, the API protocols, stuff like that, we encourage any competitor then to integrate them, because we want to be interoperable, because we don't want to become like a cash app sort of app where it's locked in. It's an amazing app, but it's all locked into, you know, your Cash App. Literally, only people who use Cash App can use Cash App. The advantage of Lightning is it's integrated absolutely everything into one another. So it would be an honor to basically, even if we build out the protocol for doing things, we want other companies to come and integrate that too into their own products, even if it's like not to the same scale as we do it. Just sort of having that experience, because we're going to build that experience if it gets implemented as a standard or not. Right, we're going for something, and you know we're going for a vision, and whether people want to integrate that or not is up to their choice. But we're trying to make it at least the best choice that we can see, I suppose. At least not just for us, but also for, if anything, it's more for the user's choice. Because you know we can't just go back to being like we can't take the same values as like a legacy Web 2 company in this sort of thing, which is hold on to users' data at all costs. Don't let them move away from their accounts. Basically, be a pain in the ass to everyone who uses your app. Especially, for example, I'm at college. I'm switching between note apps currently, between Notability and GoodNotes, and it is such a pain because I want to use GoodNotes just because it's a little bit better and has a few different features. But then the trying to get Notability to then move all my content over from and all my history and notes I've written about my subjects into GoodNotes is such a pain, right? But then I want the experience, like I want to be able to download our app, use our app, our open source hardware, which open source also means you can integrate it. Other companies can integrate our first party hardware into their products also, if they wanted to. And even build like basically a competitor using our own open source hardware. But we want people to be able to switch from our app to the competitor's app, to try the competitor's app, and then hopefully also move back to our app. But
Right.
but the last bit's obviously just a business move rather than, you know, anything else. But yeah, there's definitely a balance.
Yeah, and it's important that there's interoperability. I think that's one of the things that makes Bitcoin and Lightning so special against the backdrop of fintech, is that we do have this interoperability where you can move funds, and you should be able to interoperate between a lot of different apps. And you see all the different ways people are earning sats now. It's like you can earn sats in a game, you can send them to Stacker News, you can do this, and all of it is using the same currency, which is, I think, a special feature that we should be embracing. I want to touch on one more point on, you guys are focused on hardware and software. And it reminded me of a quote from Alan Kay, who was he helped design one of the first desktops at Xerox PARC, very influential in Steve Jobs' life. And his quote was that people who are serious about software should make their own hardware. I want to hear from you about what advantages you think will emerge from the fact that you're building both hardware and software.
First of all, I love that quote. It really matches what we're doing and sort of the values and ethics we have definitely here, and what I want to take, where I want to take the company, because we've sort of ever since like we even started everything and like coming together, it's been sort of the idea that software just isn't enough on its own, no matter how cool the software is, how much you optimize it and everything. It won't be as cool as if, because ultimately it's got to interact with the real life. In the real world, we've got to you want to make payments with it, you want to charge your EV with it, stuff like that, and that just matters. It having the hardware as well is so important to having everything work. In fact, there's everything from even the servers we run on. Like we have to think about like the hardware implications of actually running this sort of thing on production servers, running so many nodes on one server is we have to think about even like the very technical things like memory corrections. If something like a solar storm comes in from the sun and accidentally flips a bit in one of your Lightning transactions and corrupts it, we need to correct that memory, right? Many things like your Raspberry Pi won't be able to do that, and your Raspberry Pi will crash, right? And it will just basically brick itself. It could brick itself. There's a risk it could brick itself. But for example, we use ECC memory, which will then protect that. So it's definitely and especially because Lightning is so close to what we're doing is so close to the metal, you could say, that we're engineering a model around a hardware root of trust, right? That hardware root of trust cannot exist within anything except from something that's custom, right? It's something that we've built ourselves that fits into our model and does what we want it to do. In fact, the hardware root of trust is what protects users from any sort of fiat like circumstances, where because in the worst case scenario, no matter how much like legally we protect ourselves, there will be a way for example, a government agency to basically go, hey, we want to seize this person's funds, right? And we will have to immediately, for our own legal sake, we will have to, there's no option here, we will have to stop interacting with that user and providing services to that user. We will make that as difficult legally as we possibly can by registering the Caymans and making sure legally there's a lot of protections in between that go from even separating the KYC, any KYC things we do that onboard from your fiat, or anything that interacts with the fiat system, is completely isolated, both legally and also in the compute area too. Like the servers we run our fiat servers and services on are completely different to the ones we actually run your Bitcoin nodes on. Right?
Mm-hmm.
There's a lot of protections and architectural designs that basically go into protecting users' data at all costs. And even at that point, even if they get through all of that and we're forced to basically stop doing business with a user, we still want the user to have their funds, right? That's if it wouldn't be right for us to then take and confiscate their funds. That is not our decision, right? If the FBI wants to go in and raid their house, take all their live signers, and then force them over in a legal way, over in a court or something, that is not our job, right? Our job is protecting our users from governments who might not be actually doing it for the moral right, right? In countries where the government is corrupted or something, and even in like modern countries, the things that the 3-letter agencies get up to are absolutely insane when you start to look into it. I mean, I can pretty safely say that every single packet since 2005 that's ever been sent over a fiber cable on the internet is stored on the the NSA servers, right?
Mm-hmm.
There's nothing we can do about that apart from work and make choices, both architectural, legal, and technical choices about how we make our things to protect against that in the best possible way. But at the same time, we want to be compliant. We don't want to encourage money laundering or any of that rubbish or anything, because but we want the system. That's not our choice to operate. We're a finance company, not an ethics company, right?
Right.
We're not a court of law. That's up for the country or wherever the thing they are in. If a 3-letter agency wants to seize a company's assets, that is not our job to then do it for them. It's their job to get a warrant, go into their building, take the live signers, and then basically force them legally to hand over the funds. That's not our problem, right? That's not our responsibility, and we will die on that hill, right? That's not our problem. If and the thing is, and all of that relies on a hardware root of trust, right? The all of that relies on your live signers basically not trusting us, not trusting Valera. If Valera goes, hey, send me all your money, right? Because we've been legally forced to, your live signer will basically go, F off, go away. Like, you're not taking any of this, right? Because we want it to do that, right? We're building in hardware protections against us because software can be changed. Hardware that's at your house protected by, almost basically at that point, electrons and stuff that's built on hardware, we can't change, right? They will protect you at all costs, and you can trust those live signers will basically, they will effectively brick themselves before they even give up any funds, right? If you want them to do that, they should do that, right? That's your choice. They're your hardware. The hardware is open source. The software that runs on that hardware is open source. You can modify it if you wanted to. But ultimately, overall, the hardware root of trust is what makes us different from a fiat company. It's what differentiates us from even other competitors who are just software based, because software will never beat software plus hardware. There's a reason Apple products feel so magical when you use them, because your AirPods, when you flip the case open, the hardware talks to the software on your phone and pops up automatically with a click, and all you have to do is press one click automatically and it does it all for you. Whereas on Android, and you sort of get the mess that is Android, your third-party hardware. Not saying anything against Android, because I did have a Pixel 6 Pro for a bit and I did try it out, and I thought I really liked it. I ran Graphene OS on it for a while, and it was really fun. But personally, I'm okay with the risks that there are downsides to the Apple approach. There's a sort of the walled garden thing. Obviously, we don't want the walled garden here, because we're doing open source in some bits, and anything that we're not. If we were the equivalent of Apple, iOS would all be open source, right? macOS would all be open source and will be open to pull requests from third-party developers. Other companies would be helping make it a bit like Linux, right? And then some of it would be closed source, like the stuff they run on iCloud and things that they work. They have the full right to make that their own code, and don't share it with you because it's their thing. But we feel that that walled environment is not the thing we want to go for. In fact, it's probably the main reason Apple products are a pain, because apart from that, the hardware and the software integration is absolutely magical. That's how Apple was able to get off the ground and basically blow absolutely everyone else out of the water when they introduced M1, right?
Yeah.
Because Intel, AMD, none of them saw that coming, and then it took them years to come up, and they still haven't beaten the M1's efficiency because of how tightly they've integrated it from the hardware, their electron level, all the way up to their code level, right? And how good it all integrates in. And that's sort of the magic that we want to create.
I like that analogy. Maybe to finish this conversation off, we can step back a bit and think outside of Valera, outside of the projects that you've mentioned on this podcast. What are some of the other constraints, maybe some of the critical constraints that you see preventing Bitcoin and Lightning adoption today? And how do you think we should go about fixing them? Any additional kind of constraints outside of the realm of Valera?
The biggest customer for not just us, but the Lightning and Bitcoin community in general, are the countries that have less developed financial systems, because simply it's easier to compete if we don't have a competitor, right? It's a lot different to over here, where we're basically we're very spoiled with the amount of fintech stuff, and Apple Pay, Visa contactless cards, all of that is basically magic over here, and there's a lot of engineering has gone into that, even if all it is basically putting on a very pretty face over a very ugly financial system behind it. Most people around the world just only have that ugly financial system behind them, right? And even way uglier than the one we have over in the West. So the struggle is, how do we get all these features and advantages over to the countries where they don't have the things we take for granted, right? Because those are the places where we can make the biggest difference, not just on oh, that coffee was quite cool because I made a payment over Lightning, but also to the point where we're changing how communities and society works, because of how the money fits the world is a serious quote, and we need to think about how we're going to deliver that money to the world, if that makes sense. And that's probably the most important part, is just working out how we're going to get from the code on our laptops to changing the lives of one of the things I showed off to my friends was seeing a video on Twitter of a shop in South Africa selling sweets to kids with Wallet of Satoshi, right? I played the video, I paused it, I zoomed in on the video, scanned the QR code, and sent them $2 from my phone instantly in front of my friends, and that was so mind blowing for them, right? But it's the people like that who we want to support. That basically it's actually what the market, the first market, because obviously there's a lot more competitiveness in, because we've got to beat like modern Apple Pay, for example. Beating Apple Pay's user experience is going to be a long while out yet. even for us and for our tech, like as much as we need to do, there's still hardware involved and stuff like that to and people have got to get used to that over here. But we need to think about how do we bring those benefits to the people who don't have all of that in the first place.
Makes sense.
Where they don't have internet in every home, where they don't actually have smartphones, but rather the connectivity they have is just SMS, for example.
Yeah. And making a magical experience may be easier, as you mentioned, in the places where, they don't already have that pretty interface to rely on. And, there's billions of people that can see their lives dramatically improved by this technology. And now it's just a matter of, making an experience that they enjoy using.
Exactly.
All right, let's finish this off with one final segment. It's called the lightning round. I got a few rapid fire questions for you.
All right.
I hope you're enjoying the show so far. Just a quick message from our sponsor. Stackwork is a lightning-powered platform for generating high-quality transcripts of all your audio or video content. They combine AI engines and hundreds of human workers all over the world who are paid over the Lightning Network to assemble these transcripts. And that's what lets Stackwork create better, faster, and less expensive transcripts. To see the results for yourself, I use Stackwork on my personal website where I transcribe all of my full-length podcast episodes. Check that out. And if you want to learn more about Stackwork, visit stackwork.com. That is STAK work.com. First question, how many people will be operating a Lightning node in a decade?
In a decade, 250 million to 1 billion.
Wow, it's one of the highest numbers I've heard. I think I've heard one guest who said over 1 billion. But I like it. If you could only hold one asset for the next decade and it could not be Bitcoin, what asset would it be?
For the next decade, just an asset in general, or like?
Yeah, any asset.
Sure, probably real estate. It's people. That's always a solid place to go. Usually, even if the world collapses, people will need houses. So, or if you wanted to be a lot less moral, you could invest in defense companies too, because they make a lot of money, and no one's touching their defense budget for quite a while yet. So,
right.
Makes Whether sense. It's an ethical decision is a different problem.
Yeah. Has there been any book that has meaningfully changed your view of the world?
The one I've got here is The Age of Surveillance Capitalism.
The Age of Surveillance Capitalism?
Yeah.
Okay. And then final question, is there anyone in the Lightning or Bitcoin community that you'd like to give a shout out to for the work that they are doing?
First one that comes to mind are both Lightning Labs and Dusty. Lightning Labs is working on Taro. Taro is a massive deal. Lots of people don't think it is. It's way bigger of a deal than people think it is, because once you sort of we're basically tricking people into bringing their fiat onto Bitcoin. So then when fiat inevitably collapses, everyone goes, oh, why don't we just use Bitcoin instead? And to Dusty, because he's working on splicing and he's done basically most of the work as far as I'm aware. I don't want to, put any presumptions out there, but he's done a lot of work on splicing, which is one of the magical features that we have to integrate, and we probably have the pleasure of making a pull request into LDK to support.
Awesome. Happy to hear that. And thank you for taking the time. This was an incredible conversation. I really enjoyed this, and I hope we can do it again soon.
Sure, I'd love to. Thank you.
All right, it's only been a few hours since I posted my last video with Alex Edelman, so there are no new comments in from listeners in the last few hours, but I will be keeping an eye out over the weekend for all the comments, sats, questions you guys send in, and keep an eye out for a few new episodes coming up next week. Talk soon.